Okay, welcome back. In our last lesson, we looked at the addition and subtraction of matrices. This lesson will focus on matrix multiplication. Size will once again be important for this operation. However, unlike addition and subtraction, where the size of the matrices had to match exactly, the condition for multiplication is as follows. The number of columns in the first matrix must match the number of rows in the second matrix. So when we list the size of a matrix, we list the number of rows first, followed by the number of columns. The number of rows, followed by the number of columns. If these two numbers match, the multiplication can be performed, and the result will be an n by m matrix. In other words, a matrix that has n rows and m columns, respectively. Okay, I will explain this further as we go through our first example. On the left side here, we have a matrix with 1, 2 rows and 1, 2, 3 columns. It is a 2 by 3 matrix. We are trying to multiply it by a matrix with 3 rows and only 2 columns. It is a 3 by 2 matrix. These numbers match, so the multiplication can be performed. What will be the dimensions of the final product? It will be a 2 by 2 matrix. In other words, a square matrix, one with 2 rows and 2 columns. Now I'm going to show you how you figure out the elements for the product. So there will be, again, 4 elements in total if it is a 2 by 2 matrix. So 1, 2, 3, 4 elements in total. To figure out the element here, we note that it is in the first row and the first column. So we form it by multiplying the elements from the first row here by those in the first column here. 0 times 3, negative 1 times 1, and 2 times 6. This element can be described as being in the second row and the first column. So we take the second row here and multiply it by the first column here. 4 times 3 plus 11 times 1 plus 2 times 6, like this. To form the element in the first row and the second column, we take the first row here and multiply it by the second column here. 0 times negative 1 added with negative 1 times 2 and 2 times 1. Lastly, for the element in the second row and the second column, we take this second row here and multiply it by the second column here. 4 times negative 1 is added with 11 times 2 and 2 times 1. Now we just work out each of these numbers. Okay, so this would be 0 added with negative 1 and 12, so that's 11. Here we have 12 plus 11 plus 12, or 35 here. 0 plus negative 2 plus 2, which is 0. And here, negative 4 plus 22 plus 2, which is 20. Okay, let's try a second one together now. in our second example, we have a matrix with 3 rows and 2 columns. So it is a 3 by 2 matrix. This one to the right has 2 rows in 1 column. So it is a 2 by 1 matrix. What final size should our answer have? It should be a 3 by 1 matrix, which means 3 rows but only 1 column. Let's figure out what numbers will be in the 3 by 1 matrix. So for the first item, it will be in the first row and the first column. So we take the first row here and multiply it by the first column there, like this. 12 times 25 is added to negative 47 times 66. Okay? Now we want the second row and the first column. So we take the second row here, multiply it by the first column here, which of course is the only column here. So 43 times 25 is added to negative 18 times 66. Lastly, for the last item, which is considered to be in the third row, but the first column, we take third row multiplied by first column. So 36 times 25 is added to negative 22 times 66. And then certainly you would want to use your calculator to work these things out, okay? And I think you'll find you should get negative 2802, negative 113, and negative 552. Maybe I'll just check that quickly before moving on. Yeah, those are fine. Okay, so let's try a third example. Okay, so in example 3, we're multiplying 2 square matrices. Their sizes are each 2 by 2. The fact that these numbers match means that the multiplication exists. And the dimensions of the final answer are given by these numbers. The final answer will have 2 rows and 2 columns. So let's figure out how to form those entries. In the first row and the first column, we multiply these numbers by these numbers. So negative 7 times negative 90 is added to 8 times 10. For the entry in the second row of the first column, take the second row and multiply it by the first column. So 5 times negative 90 plus 0 times 10. For the entry in the first row, but the second column, take first row and multiply by second column. So negative 7 is multiplied by 100, and to that we add 8 multiplied by 40. And for the last element, which is second row, second column, take second row and multiply by second column. So 5 is multiplied by 100, and to that we add 0 multiplied by 40. Okay? And then each of these works out to give us a corresponding element in our 2 by 2 answer. All right, so you can do the math again with your calculator if you like. So this looks like 630 added to 70. So that's 710. Here we're going to have negative 450 added to 0. Here, negative 700 is added to 320, so that's negative 380. And here we have 500 added to 0. Okay, so at that point we're done. Okay, let's try one more example. Here we have a square matrix with 1, 2, 3 rows and 1, 2, 3 columns. So its size is 3 by 3. Beside it, matrix B has only 1 row but 3 columns. So it's considered to be a 1 by 3 matrix. So the question is, can we find product A times B? And can we find product B times A? So let's consider those one at a time. A times B would mean taking a 3 by 3 matrix and multiplying it by a 1 by 3 matrix. These numbers do not match. In other words, the number of columns in A does not match the number of rows in B. This is not possible. So the operation cannot be performed. But what about the multiplication of B by A? So B is a 1 by 3 matrix. If we attempt to multiply it by A, which is a 3 by 3 matrix, we have these inner numbers matching. The number of columns in B matches the number of rows in A. So the multiplication is possible. What will the dimensions be? The dimensions will be 1 by 3. So our final answer will have only 1 row but 3 columns. Let's try that multiplication now. So we're multiplying B by A. So B by A. So I've copied that all down carefully. And now let's try to figure out the 3 entries in our 1 by 3 result. Okay, so we're doing the first entry, which will be in the 1 row. So the first row we can say, and the first column. So we take the first row, multiply it by the first column. So 4 times negative 2 will be added to negative 1 times 3 and added to 5 times 0. That's going to be the first item in our answer. Okay, so that ends up being negative 11. And to form the second element, which will be in that first row and the second column, we will multiply this row by this column. So that will be 4 times 1 added to negative 1 times negative 1 and added to 5 times 2. And you can do the calculation here quickly. You should see that that's 15. And now we'll do the very final entrant. So we're going to take, again, first row multiplied by third column. So 4 times 7 will be added to negative 1 times 0. And then we add 5 times negative 1. Okay, and you can check this. It's 28 minus nothing minus 5. So 28 subtract 5, I think, should be 23. Like that. Okay? And at that point, we're done. So this last example, example 4, just showing you that it is possible in this case to multiply B by A, but not possible to multiply A by B. And again, that's because of the original conditions that we discussed at the beginning regarding the necessary sizes for the multiplication to exist. Okay, so thanks for watching this small lesson. Check Blackboard because I will have suggested problems listed for you from 16.2 of your textbook. Okay, have a great day.